Hello and welcome to Techie Hive. In previous video, we talked about HashMap and we explained how HashMap works internally. Today, we'll discuss another top Java interview question and the question you can see on the screen. What is a Java thread? What is the difference between synchronized method and asynchronized block? So by asking this question, interviewer wants to understand that you know what is multi-threaded programming, what is critical section, and how to synchronize the, threads when they access a shared resource. So let's jump into the answer. In Java, a thread is a lightweight unit of execution. Basically, it's a path of execution within a program. Every Java application runs at least one thread. So by default, a single thread is created by the Java program, but you can create and run multiple threads to perform tasks concurrently. Let's say you want to do a few tasks in at the same time concurrently. In that case, you can create user-defined thread or custom threads. In this diagram, I have shown that main thread has two children, thread 1 and thread 2, and thread 2 in turn has two other children, thread 2 1 and thread 2 2. And I also have showed the shared resource over here just to explain why we need thread synchronization. So let's say thread 1 releases data from this counter and the value of the counter at the time is 20. Okay, so it's increasing the counter over here. While it's increasing the counter, thread 2 goes over there and reads the counter and it will read that 20 value again. Okay, so it will read the 20 value again, and now because thread 1 has finished its increment or its task, it will update the value to 21, right? Now, when thread 2 finishes task, if it will update back the value 21 because they read the same value 20 from there. So that means the data is now consistent. Data is not consistent now. So it should be 22, not 21. But that means the data is corrupted. So to solve this problem, we need a thread synchronization. So where we have to make thread 2 to wait until thread 1 finishes task, and that is called uh, resource synchronization. So when thread 1 is updating this counter, thread 2 has to wait. And once thread 1 finished its task, then thread 2 can go and update the resource. So in that case, data is consistent. On the other hand, thread 2 1 and thread 2 2, let's say, are reading from this shared data or this counter. So in this case, like we don't need any synchronization because it's just reading, they are not updating. So whatever current value is there, they will read that. It doesn't matter who updated that value, eventually. So for reading, we don't need any thread synchronization, but for writing, we need thread synchronization. And thread synchronization in Java is done through synchronized methods and synchronized blocks. So both synchronized method and synchronized blocks in Java are used to prevent race conditions. When multiple threads try to access or modify shared data at the same time, they ensure that only one thread at a time can execute the synchronized code on the same object so that data remains consistent. In case of synchronized method, when a thread enters into a synchronized method, it locks the entire method and acquires the instancing lock on that object. So each object has its own instancing lock. And when a thread enters into the synchronized method of that object, thread acquires that lock. And all of the synchronized methods of that object are logged, and no other thread can enter into any of the synchronized methods. So here you can see that if one thread enters into any synchronized method of the object, then all other methods are also logged. So other thread cannot, execute any of the synchronized method. However, they can execute non-synchronized method, but all of the synchronized methods are logged. Advantage of using synchronous method is easy to implement, and so that safety of the whole. It's very simple. We can just put synchronized keyword with the method definition, and it will block or it will log the entire method. Disadvantage, yeah, it's small, it's less efficient, and if you want to log a part of the method, right? We don't want to log entire method. We just want to log, 10% part of the method. Then, we have to log entire method, and 90% of the code which other thread could execute is also blocked. So this is a disadvantage of the synchronized method. On the other hand, synchronized block only blocks a specific section of the code using a specific log. So uh, the critical section which is used in the block section is very small in comparison of the synchronized block. So critical section is the code which we need to synchronize. Advantage, better performance. Yes, we don't need to log entire entire method, so other thread can run concurrently in the other part of that method. More fine grained control, yes, synchronization, because we can control it, like which part of the code we want to uh, synchronize. And it's slightly more complex because we have to do some we have to find out which part of the code we have to synchronize and which part we need to leave unsynchronized. Yeah, so here is an example of synchronized method and a synchronized block. It's very simple to define a synchronized method and a synchronized block. So here it's very simple. Synchronized increment counter class. So generally you can see here we have put synchronized method, sorry, synchronized keyword before just method return value, and now this entire body of the method is logged. So this count plus plus and also other part also logged, and then we can get the count from here. On the other hand, you can see we have we have just used the synchronized keyword inside the method. Okay, so this is synchronized block. So here we have only blocked the count plus plus, right? So when one thread is increasing count, other thread has to wait, and the other part of the method are not logged. So other thread can execute this part. So this is the advantage of using synchronized block, and then we can get the return value from the count anytime if we have any read thread. Here is a summary of synchronized methods. In Java, we can have two types of methods which can be synchronized. Non-static method, which are called instance method, and static method, which are called class method. So in case of non-static, means instance methods, log is acquired on the current instance. Okay. Only other synchronized instance methods of the same object are logged, as I mentioned earlier. If we have logged one a non-static method of a class, then all other non-static methods, like all other synchronized non-static method, will be also logged. Other thread can still access here a non-synchronized method of the same object, synchronized methods of the other objects of same class, and static synchronized methods. Since those are they use a different log. We will explain it through the example later. In the case of class synchronized method, lock is acquired on the class, not on the single instance, and all threads calling static synchronized method of that class share the same lock. So that means when we have synchronized static methods, and a thread enters into a synchronized static method, then all other static synchronized method will be logged. It does not lock instance, non-static other, because those use the instance log, this, not the class log. Yeah, let's see this by this simple example. Here I have created a sync example class, and inside this example class, I have created two synchronized instance method and two synchronized static method. And after that, in the main function, I have created two objects of the class, and I will use these objects as the lock. Now I am starting three threads, sorry, five threads over here. So first three threads are uh, calling the instance methods, different instance methods on the same object. Because the lock is on object level, so these three threads will compete to each other to acquire the lock. So there would be race condition. And the fourth thread is calling the instance method of object 2. This method is synchronized, but here the lock will be put on the object 2, not on object 1. So this thread will allow to execute this method. And the last thread is calling the static method of the same class. So this is also, acquire the separate lock. Okay. So now let me run this example and see what happens. Yeah, it's finished. Now you can see here. So thread one get the lock. Okay. Here, thread one first get the lock. So that means thread two and thread three need to wait until thread one exits from the function or the synchronized function, right? And once thread 1 exits, you can see here, thread 1 exits here, then thread 3 acquire the lock on the instance method 2. So now thread 2 has to wait, right? Because the same lock is used on the synchronized method. So object 1 lock is used for instance method 2 and also for instance method. So that means thread 2 has to wait. And now here you can see thread 3 exits, and after that, thread 2 entered and exits. That means when thread acquires a lock on an object, all of the synchronized instance method for that objects are locked. So only one synchronized method can be executed by a single thread. No other thread can execute any of the synchronized method. And other threads can execute those methods if lock is on the different object, and similarly for the if lock is on the class level. Now let's see how static method works then, how static methods are synchronized. Okay, so now I will just comment it out this code because this for instance methods. Okay, and now here I'm using this again, like a similar kind of thread structure. So I have created 4 threads over here, and first 3 threads are calling the static methods of the class. And you can see here this static method is also synchronized, right? So here the first 3 threads will compete to each other to get the lock, because here lock is put on the class level, and other object or other thread can run the instance methods of the class, because here lock is not put on this this, sorry, here lock is put on this one, not the class. So class lock is separate from the object lock. Okay, so let me just run it and see how it works. Okay, now you can see here. So out of these threads, right, only one thread acquires the lock to the static method, and this is thread number 5 first. Okay, first thread. And then thread 6, sorry, thread 7 will acquire the lock when thread 5 exits. And similarly, when thread 7 exits, then the lock is acquired by the thread 6. Okay, and you can see here the thread 8 is not blocked here. You can see here it's not blocked, so it will execute immediately, without without any problem. So that means on if we have the if lock is put on the class level, then all of the synchronized static method of that class are locked, and other thread can execute the instance method. Okay, so now this was for a synchronized method. So I have created the same example using the synchronized block. So let me go there here. Okay, so I have created the same methods here, and now what I have done, instead of putting the lock on the entire method in the synchronize method, like I have put here lock on the small part of the method. So this method is not synchronized. However, this part is synchronized. So any of the thread is free to execute this part and this part, because this is not synchronized. This is not critical section. And you can see here lock is put on the object level here. Okay. So what will happen when a thread comes over here, then it will lock this object, entire object, and will go into the in this critical section. And when exits, leave the lock. Okay, and this is method 2, and similarly for the starting method, I have put lock on the class level here. You can see here class level. Okay, and similarly, like I have the same examples over here. So first, let's execute this one. So here you go. So now you can see that out of these three threads, because the lock is put on the class level, right? So these three threads will compete to each other, and one of them will only acquire the lock. And let's see which one got chance. So here we can see, yeah, thread 6 acquired lock on the method 2. Okay, that means thread 5 and thread 7 has to wait. And now when 6 release the lock, after that 5 acquire the lock. See, thread 5 acquire the lock, and when 5 release the lock, then 7, yeah, means thread 7 acquire the lock. So that means uh, when lock is put on the class label, okay, in synchronized block, then only one thread can enter into one of the synchronized blocks. Okay, let's comment out this code and see how a synchronized block works for the object level log. Okay, so let me just uncomment out this one. So here again we have created two methods, and inside these methods we have a synchronized block over here, and this synchronized block is logged on the same object. You can see here this on this class object, this object. And here we are running again, 5 threads. 2 threads will run independently, but these 3 threads will compete to each other. So only synchronized method will be executed one by one. So let me just run it. Here you go. So now let's see which thread got the log out of these threads. We can go to the logs here, and now see here uh, thread one acquired the log. Okay, so here you can see thread 1 acquired the log. So thread 2 and thread 3 has to wait until lock is released. And now see when thread 1 is releasing the lock here. Yes, you can see here thread 1 release lock, and immediately after that thread 3 acquired the lock. Okay, and now thread 2 is still waiting. So when thread 3 release the lock, then thread 2 will acquire the lock. Okay, that's all I wanted to cover in this video. Hope you like it. See you in next video.